Today's lesson is going to continue with the ideas that we were using yesterday, talking about the correlation values. So our goal today is to be able to get close to guessing the actual correlation for a series of data. Remember, we talked about how correlation, which is represented by the variable r, measures the strength of a linear relationship between two quantitative variables that has values between -1 and 1. So we have some scatter plots here we're going to start with to do some practicing, make sure we're on target. Then we're going to take a look at 6 other scatter plots to see how we're doing with that, and then we'll look at our application for today. So we're going to take a moment and pause the video and look at these first 3 scatter plots given to us. So there are 1 and 2, and here is 3. And I want you to guess the correlation value, the R value. Tell me if you think it's a positive or negative correlation. Do you think it's weak, moderate, strong, or very strong? So again, let's take a moment, pause the video, and answer those 3 questions. All right, so for our data set in number 1, the good guess for the R value would be 0.551. That's its exact R value. We can say that it is positive and that it is moderately strong because it's in between our value of 0 and 1. So we got a moderate and positive relationship. Going to our data set for 2, based on what we see here, the exact R value is negative 0.994, which means that we'd have a negative relationship, and it would be very strong. So again, we have a very strong relationship because it's close to that -1 value. If it was a positive relationship, it would be very close to that 1 value. For our data set 3, the R value there was negative 0.1. So it's close to 0, which means we can see somewhat of a negative correlation because of our x's go up, the y's do decrease, but it's a pretty weak relationship because it's close to 0. All right, we're going to take a look at 6 other data sets. Here are some applications. Again, you're going to guess the correlation coefficient, or R value. Tell me if you think it's a positive or negative relationship. And would you classify it as weak, moderate, strong, or very strong? So our first one is talking about the points per game and the wins. Then we have the number of boats registered in Florida and the number of manatees killed. And then we have the storms predicted versus the storms observed. So let's pause the video again and work on these 3. All right, we've got our explanatory variable being the points per game, our response variable being the number of wins. The correlation coefficient is 0.93587. We have a very strong positive relationship here with those data points. As we take a look at the number of boats registered in Florida and the number of manatees that happen to pass away, this is from 1977 to 2010. Again, we can see that it's a positive relationship. The R value is 0.95298, so it's very strong again. Our last set of data, the number of storms predicted as your explanatory, the storms observed as your response. The R value here is 0.5. I would say it's positive. And it's a moderate relationship because it's in between 0 and 1. All right, let's turn it over and take a look at another 3 sets of data. We're going to look at the healing rate for limb 1 versus the healing rate for limb 2. We're then going to look at last year's percent return versus this year's percent return. And lastly, the number of years since 1990 and the number of active clusters. So pause the video and answer those three for the correlation coefficient. Positive or negative relationship, is it weak, moderate, or very strong? All right, our explanatory variable for healing rate limb 1, response is limb 2. The correlation coefficient is 0.3, so it's a positive but weak relationship. When we look at last year's percent return as the explanatory, the response for this year's percent return, the R value is negative 0.1. So we can see it's a negative relationship where you see decreasing, and it's weak because it's very close to 0. Our last one here, we've got the year since 1990 as your explanatory. Your response are the active clusters. Our R value is 0.98419, so it's positive and it's very strong. So again, let's recap the big ideas from today. We also stressed these yesterday as well. We know that the correlation coefficient is on the sliding scale from -1 to 1. And the very strong relationships are at the ends of your scale, right? So if it's a very strong positive relationship, it would be 1, a very strong negative relationship, -1. And we made sketches of those graphs yesterday in our activity. If there's no correlation, extremely weak, it's going to be around that 0 point. And moderate is kind of within that like half, -1/2 realm. So we use this to talk about the strength and direction for our data values. Whenever we need to interpret the R value, we would always say the correlation R equals whatever value it was, indicates our linear relationship between X and Y, or your response, your explanatory and your response variable, and you would state what direction and strength that it had. So it's a template, you're just filling in the information from your problem. So you're always going to give the value. You're going to talk about the explanatory variable as your X, the response for your Y. You're going to give me the strength and the direction of that data set. The form, typically we look for linear relationships, but we know not everything is linear. We also know that R being close to 1 doesn't always guarantee a linear relationship, so it's okay if it's not. Just say it's nonlinear, and if you can identify one of your nonlinear patterns, like an exponential, a quadratic, a cubic, absolute value, something along those lines, that would be great. But again, you'd want to specify it's nonlinear versus linear first. We also have to remember that the correlation coefficient is talking about the direction and the strength of the relationship, but we have to remember that correlation does not equal causation. We talked about this first semester. We could take any two variables, right, and get data for them, but it doesn't mean that your explanatory necessarily causes the response variable for happening. So correlation does not always equal causation. So with what we worked on today, you're going to take a look at your application for 2.3. If I eat chocolate, will I win a Nobel Prize? So again, remember, most people love chocolate for its great taste, but does it also make you smarter? The scatterplot below recently appeared in the New England Journal of Medicine. The explanatory variable is the chocolate consumption per person for a sample of countries, and we can see that with the flags. The response variable is the number of Nobel Prizes per 10 million residents of that country. So again, here's our graph depicting the situation. And we know that the correlation coefficient is 0.791. You're going to give me an interpretation of that. And then you are also going to tell me if the people in the United States started eating more chocolate, can we expect more Nobel Prizes to be awarded to the residents of the United States? Why or why not? So you're working on that with your peers. Before you did see the 2.3a application. Again, please make sure you're working on completing that. We'll take a look at that at our next class tomorrow and go over it in more details.